Okay, we are back for another daily proof. So, again, we're given some stuff here we're trying to prove. We need to mark on here what needs to be, what is already given, I should say. So, it looks like we're given that AF is congruent to EF, those two segments. Segment AF is congruent to EF. Okay, I'm going to mark that. And then segment FB is congruent with segment FD. FB is congruent with FD. So this is congruent with that. And then angle BAF, BAF is congruent with DEF, DEF. BAF is right there. DEF is right there. All right. Okay. So that's all nice and well. Now, we need to prove that CAD is congruent with CEB. CAD, this bigger triangle, is congruent with CEB. CEB, this bigger triangle. You can see they share this figure down here, this quadrilateral. Okay. Well, it's a good thing we're not trying to prove this triangle is congruent to this triangle, because you'll notice that's ASS or SSA, right? And we're not allowed to use that. But that's not what we're doing. Bigger one and bigger one. Do you see anything that we can mark on the triangles that are congruent? Do you see anything else we could mark? Pause here. See if you can figure it out. Yeah, I see something. Again, like last time, we could mark these vertical angles. But again, those vertical angles are not part of the triangles we're trying to prove, so that's not what we're going to mark. Instead, if we're talking about triangle CAD and triangle CEB, you can see that they both have this angle. They share this angle. So I'm going to mark this as congruent with itself. Okay, I do two arcs. Mr. K does an arc and then two lines. That means the same thing. Okay, now, I think we may have enough, right? You can see, if we're just talking about, say, this triangle here, CAD, we have this angle. It's congruent with itself. We have this angle. It's congruent with that one. And then we have this side that's congruent with this side. Do you see how I know that? Because it's this and this. See that? It's 1 dash, 2 dash, 1 dash, 2 dash. That means this whole thing is congruent with the whole thing. Now I have to figure out how to build that up. But that's the idea. So let me just real quickly do the outline over there. Okay. So it looks like we're going to do AAS, right? So the first A is this ACE, right? We have, actually, no, let's do the given one. Let's do what's given. Although, well, that's not in the right order. No, we'll do CAD. So notice that, excuse me, ACE. Angle ACE is congruent with angle. And I'm going to do it in the other order, because you'll notice that in this, when we're talking about these, they are in the opposite order because it's kind of it's a reflection, okay? So ACE is congruent with ECA. Triangle ECA, okay. And then the second one that's given, triangle, or excuse me, angle BAF is congruent with angle DEF. And then this last thing that we're going to have to build up, figure out how to build up, segment AD is congruent with segment EB. And again, it's the same order as in the triangle proof statement. AD is congruent with segment EB. Okay, so that's my outline. All right. Now, let's figure out this proof. I'm going to say this first thing, right? ECE, ECA. Okay, so angle ACE is congruent with angle ECA. Do you know the reason for that, folks? You know what I'm going to write right there? It's congruent with itself. Remember what that's called? The reflexive property. Okay, nice. Second thing, we got angle BAF is congruent with angle DEF. And of course, that was given. Okay, and then the last thing. So here's the idea. I need to build up to the fact that those two are congruent with each other. Okay, so first, the idea that if I add them up, they equal the bigger piece, right? AF plus FD equals 80. So I need to say that, okay? So the way that I'm going to write that is segment AF plus segment FD is equal to segment AD, right? AF plus FD is 80. I want to do the same thing for the other ones. If you haven't done that, you may want to pause right here and see if you can write for the other triangle. Okay, pause here. All right, so segment EF plus segment FB, EF plus FB is equal to EB, that segment. All right? Okay. Now, why is that true? It seems pretty obvious, right? It's true because that's how addition works. That's what addition means. So it is the additive property, or the addition property would be fine. Okay? Right. And from that, okay, I can state what was given, because I'm going to add those two together to get to this last statement here. Okay? So I can write segment AF is congruent to segment EF, and segment FB is congruent to segment FD. Okay? And of course that was given, right? Okay. And so now with those two things, I can say with confidence that segment AD is congruent with segment EB. Okay? Right? You can say, I added them up, right? And then I used what was given, and now I can say these are congruent to each other. Okay? The question is, what is my reason for that? What is my reason for that? Truthfully, I'm not sure. What would be a good reason for that? Is it, so I add these up, this plus this is that. This plus this is that. These are congruent, these are congruent. Okay, so then this whole thing is congruent. Okay? No, is that also the additive property? Because that's how addition works. We're going to go with that for now and see what happens. Okay, now I have my three things. Okay, so I can say with confidence that triangle CAD is congruent with triangle CEB. Alright, and that is using the AAS triangle congruence method. And we're good. I think that is it. I hope that was helpful. Take care.